The premise. The premise was to create a render of an image using PBRT, rasterization, and ray tracing. These renders were to be made using only code apart from PBRT, which was used as a plugin for Maya. Creating the scene. The first thing I did in the creation of the scene was find a reference image. I originally thought of doing a still life with cheese and wine, but most people went for that idea, so I settled on something a little more unique. Finding similar assets was quite hard, as most assets were not similar in any way or cost a lot of money, so this is what I went with. I had to edit the textures from the original red to the current rusty look. I got the dumpster model from Sketchfab as well as the tire model, but the metal part of the wheel was made by me. PBRT. To start the PBRT, I had to extract the files from GitHub. This was done through Git Bash. I then used CMake to build and set where the files would go. Running it through Visual Studio, then created the files I needed. Then I went into Maya and used the script editor. I entered this line of code which located the plugin and applied it to Maya. I then gave all the objects PBRT materials. Some appear as white, such as metal and glass, as they can only be viewed when rendering. Here are the render settings for PBRT. I had to change the screen size, the resolution, and the chosen file format, which is TGA. The PBRT uses these coordinates for the camera position and the look-at position. These are the same for both the rasterizer and the ray tracer. Here's the final PBRT render. I'm happy with how it turned out, as I think it looks quite nice. It's a TGA and it's 1920 by 1080. Rasterizer. To begin with creating the rasterizer, I created these files for the code. Here is the geometry header code. This code is responsible for defining the vector2 and vector3s for geometry models. It also defines the matrices. Here is the code for the models. This code is using the rasterizer CPP to get the vertices and faces of the models. Here is the header file for the TGA image. And this is the TGA CPP file. Here is the rasterizer code. This code is responsible for the entire thing. The code itself gets all the objects that have been set and then outputs them in a rasterized image. The image is fully rendered and is also written as a TGA file. The rasterizer uses these coordinates for the camera position and the look-at position. These are the same for both the PBRT and the ray tracer. Here is the final render for the rasterizer. I'm happy with the result. As you can see, it's fully rasterized and has back face culling, so you can't see the unseen faces. This is also at 1920 by 1080 and is a TGA export. Ray trace. To begin with the ray trace, I created these scripts. This is the triangle header code. This code declares the vertices and the normals of the triangles. I ran into an issue at first where my glass and metal were just black. Everything else, such as lambda and light, worked fine. To fix this, I created an extra triangle class called Advanced Triangles. This one had proper normal, which was what stopped it from working previously. This fixed it and allowed for metal and glass to work. Here is where all the materials have been created. These include a diffuse light, Lambert, metal, and a dielectric for glass. Here is a code where the faces and vertice variables have been declared for the models. Here is a Model CPP code for actually sorting the faces and variables of the models. Another issue I had was with the speed of the render, which originally took hours. This was fixed by adding the BVH code. This helped speed up the process as it made sure that only the models were being rendered in instead of the whole image at once. So it gets the outline of the shape and just renders that. Speeds it up. Here is the Ray Trace CPP code. What this code does is create the models and retrieves their faces and vertices, as well as outputting them into the scene and give them appropriate materials, also declared in this code. It also is responsible for shooting the rays and processing those rays. The scene runs at 500 samples per pixels to give a high quality render. The ray tracer uses these coordinates for the camera position and the looker position. These are the same for both the PBRT and the rasterizer. Here's the final render for the ray tracer, rendered using 500 samples per pixel. This is the one I was happy with, as I originally did another 500 samples per pixel render, but wasn't happy with it, so I redid it again, and I got this one, which I'm very happy with. It's got metal, glass and lambert, and thank you for watching.